Hello kids, Shubhamangalam Academical Scholars. Myself Sudeep. I'll be taking class 10, chapter 1 for today. The name of the chapter is Reflection of Light at Curved Surfaces. So in earlier classes we have studied about reflection of light at plane surfaces. So today we will be studying about reflection of light at curved surfaces. So now for your convenience I've also mentioned the page number. It's page number 1. Okay, that's what we're going to start today. So now, looking at the name of the chapter itself, we see the terminology reflection over here. What do you understand by reflection? In earlier classes also, we have studied a very basic definition of reflection. Reflection is nothing but the bouncing back of light. Yes. Now, if I consider a plane mirror and I project a torch light on it, as soon as I switch on the torchlight, the light is going to get projected on the plane mirror and it is going to bounce back from the other end. Remember the laws of reflection? There are two laws. The first law states that all the three rays lie on the same plane. And the second law is angle of incidence will be angle of reflection. Okay, we will deal with this later again. For now, I was just clearing the concept of reflection with you and I was just recalling it. Reflection is nothing but the bouncing back of light. But what we have studied earlier is that this bouncing back of light was happening on a plane surface. Now, we will be studying about reflection of light at curved surfaces. And these curved surfaces are nothing but the spherical mirrors that we are going to study about. We will also study why are they called as spherical mirrors. So before that, we have few questions to be dealt with. The first question being, is the image formed by a bulged surface same as the image formed by a plane mirror? Now plane mirror is nothing but your dressing mirror that you see every day. Okay, as soon as you get up in the morning and you get ready for school, you see yourself in the mirror. That mirror is nothing but an example of a plane mirror. Do you see yourself every day different, bulged out or squeezed in? No, you appear the same as you are. Of course, because that's a plane mirror. Now the same case would be different. If you have ever been to exhibitions or circus, you know there are different kinds of mirrors placed over there of different shapes and sizes. Some of them are bulged out, some of them are really thin, and they, as soon as you appear in front of them, you look different. You look either as if you have, bulged out like a balloon, or as if you have squeezed off like a small straw. This happens usually in exhibition and circus. Why do they place them there? So that people are interested to watch, such different kinds of mirrors. So it is a piece of, scenic beauty that people like to watch themselves different over there when they are placing different kinds of mirrors, so it attracts the audience. That is why they are placed. Such kind of mirrors are usually placed in circus or exhibitions where you can see yourself bulged out or squeezed in. Such mirrors are nothing but the spherical mirrors. They are basically the concave and the convex mirrors. So now when I say the bulged surface, you need to know that we are talking about the spherical mirrors over here, which are of two kinds, concave and convex. Now the plane mirror is nothing but the dressing mirror. Now the question here is the image formed by a bulged surface same as the image formed by a plane mirror? No, definitely. Do you appear the same in front of the circus mirror that I was talking about and also in front of the plane mirror? You're going to appear different in both the cases because the plane mirror is going to have a plane surface, whereas the bulged mirror is going to have a bulged surface. You stand in front of it, you're going to get a different kind of image on the bulged surface. Do you get it? For example, the headlights of the vehicle are also bulged. You can't use those particular mirrors as your dressing mirrors because you will appear different then. Okay, now the next question here is the mirror used in automobiles a plane mirror? I just talked about vehicles. Am I using in the headlights a plane mirror? If just think about it, just imagine in automobiles or in vehicles, if you have a car or a bike, the headlight, if it was not bulged, do you think it would be easy to travel during the dark? Of course not. You need to have a bulb surface, and inside the bulb surface is going to be a bulb which will be illuminated as soon as you switch on the headlights, and only then it is going to cover a wider area, and so because of this you will be able to travel in the dark. What would happen? You need to think about it. What would happen if the bulb inside the vehicle was covered by a plain mirror. Do you think it would be able to cover a wider portion of the area while you're traveling in the dark? No, it would not be possible. So you come to a conclusion over here, all of us come to a conclusion over here, that the mirrors which are being used in automobiles are not plain mirrors. They are spherical mirrors. Okay? That's the second point. So, yes, is the mirror used in automobiles a plain mirror? That's clear. Why is it showing small images? Okay, if you remember when you sit with your dad on the bike and your dad is driving, there is a mirror on the side, like the ears of the bike. Okay, that mirror is called as the rear view mirror. It is also written on that. Objects appear closer than they are. Okay, do you remember that you appear really tiny in that? Even though you're so huge and you're sitting behind your dad, you see that you appear really small inside that small rear view mirror. Okay, so that's what they're asking us over here. Why is it showing small images? That's because it is a convex mirror. It is one of the kinds of a spherical mirror which has a property of diminishing or reducing the size of an image. Okay, whereas plain mirrors don't do that. Your dressing table, does it show you much squeezed in, or does it show you much shortened in height? No, it is never going to show you that. That is why a plain mirror cannot be used in bikes where the rear view mirror is being used. The rear view mirror is nothing but a convex mirror which is going to show you a smaller image than the actual image. For example, okay, while you are driving and there is a truck coming from behind, the size of the truck is really huge. Yes or no? But the mirror is really small. But you can see the entire truck in your small mirror. Do you get my point over here? So that particular mirror has the property of, showing a small sized image showing a small sized image of the actual object which is behind the vehicle. That is why it is used as a rear view mirror. Okay. So now, definitely to prevent accidents also, if you have a truck coming from behind and you have to give it a side so that it goes away and you are at a safer place, you need to know which kind of vehicle is coming from behind. Okay, so here, point number 3. So can we see inverted image in any mirror? Do you see an inverted image in your dressing mirror? While you're dressing, do you see yourself upside down? No, you see yourself erect. Okay, definitely if you're holding a chart paper with your name written on it, the letters of the name are going to appear laterally inverted. Remember that point? We must have studied somewhere in class 8 about this lateral inversion, which is like, what was I telling is, if you stand in front of the dressing mirror, you are not going to appear upside down, you're going to appear erect. Okay, but when you're going to hold the chart paper with your name written on it, you can see that the letters on the chart paper appear laterally inverted. This is called as lateral inversion. Okay, but here we are talking about the upside down. So the plane mirror is never going to give you the upside down image, but the spherical mirrors are going to give you upside down or inverted images in certain cases, which we will deal with later. Okay. Now coming to question number 4, can we focus sunlight at a point using a mirror instead of magnifying glass? Of course, you can also burn the paper. Okay, if you're holding a magnifying glass and you're placing the paper in front of it, if the sun rays are at a certain point, while adjusting the magnifying glass, you can focus the light on the paper. You hold it more longer, the paper burns. Okay, and it turns into ashes. We know this very well. We have done such experiments, in 6 and 7 standards where you have pictures supporting this statement. Now, fifth one, are the angle of reflection and angle of incidence also equal for reflection by curved surfaces? So now, we studied about reflection at plane surfaces, and all of us know that there are two laws. I'm repeating this again. It's the first law states that the three rays, the reflected ray, the incident ray, and the normal ray lie on the same plane. And the second law states that the angle of incidence is equal to angle of reflection. So now, if I explain it to you in a much easier way, I might draw it over here. Okay, so yes. So if this is considered as the plane surface and I draw a perpendicular to it, which is my normal ray. Okay, I have my torchlight over here, which is being projected and the ray from this. So yeah, we need to discuss this fifth one point in a little bit detail over here. Now, are the angle of reflection and angle of incidence equal for reflection by curved surfaces. We know that by reflection by the reflection of light at plane surfaces, we know two laws. The first law states that all the three rays lie in the same plane, and the second law states that the angle of incidence is equal to angle of reflection. So here, if this is the plane surface and I draw a perpendicular to it, which is going to be by normal, and I have a torchlight over here which is going to project the light once I switch it on, of course. And once the torchlight is switched on, there will be a ray which will be projected on the plane surface, and that ray will be called as the incident ray. Okay, now the angle between the incident ray and the normal is going to be my angle of incidence. Now once the incident ray reaches the plane mirror, it is going to bounce back, and that is what is called as reflection. Okay, now once it bounces back, this ray, the ray which is bouncing back into the same plane, will be called as the reflected ray. But the angle between the reflected ray and the normal will be called as my angle of reflection. Okay, so now we know this law is valid for plane mirrors. We need to know whether this law is also valid for curved surfaces. Now, as per the universal law, definitely the laws of reflection are valid for both the plane surfaces or curved surfaces or any kind of surfaces. Okay, so further in the activities, we will be studying how these laws are proved to be right even for curved surfaces. Now, let's deal with what are spherical mirrors. Okay, the curved surfaces that we are going to talk about over here is nothing but the spherical mirrors. Okay, before that, the answer for this will be a big yes. Okay, anyway you see whether this answer for here is no, turn the page, you will know on page number 2. Okay, on page number 2, the second or the third para clearly explains that yes, we are right in this, and the laws of reflection are valid on both plane and curved surfaces. So here, now we need to know what are the spherical mirrors. So spherical mirrors here are nothing but, they come from the word sphere. How does a sphere look like? Okay, Earth is spherical in shape. So concave and convex actually come from the spherical mirror. So here, if I cut the sphere, okay, a certain portion of the sphere, this part will be considered as the concave part, and that part might be considered as the convex. So you need to know the word spherical mirror, or the terminology spherical mirror actually is derived from the sphere. Okay, it is nothing but a portion of the sphere that we are going to study about. So here there are two kinds of spherical mirrors that we are going to deal with, one being the concave, the other being the convex. So you need to know, in a concave mirror, the incident light is going to be projected on the internal portion. Okay, this is called as the concave mirror, where the incident light is going to be projected in the internal portion, and the convex mirror, the incident light is going to be projected at the bulged out portion. Okay, that's all.